Assalamualaikum warahmatullahi wabarakatuh. Welcome to part 2 of section 2.2. In this video, I will explain on how to obtain the state space representation from a transfer function with polynomial numerator. Let us consider this example. Note that the numerator of the transfer function, highlighted in blue, is a second-order polynomial. To convert this type of transfer function to state space representation, we need a slightly different strategy than the transfer function with constant numerator. Step 1 is to separate the system into two cascaded blocks. The first block is the denumerator block and the second block is the numerator block. In between the two blocks, we will define the first state variables x1. Step 2 is to obtain the state equations from the denumerator block. Cross-multiply the transfer functions of the denumerator block to get equation 1. Then, apply inverse Laplace to get the differential equations of equation 1. Use item number 7, 8 and 9 from Laplace theorem table and assume all the initial condition to be 0. You will get equation 2. Next is to define the state variables. From the transfer function, we know that we need 3 state variables because the system is a third-order system. The first state variables x1 is already defined in step 1 in between the denumerator and numerator blocks. Thus, we only need to define two more state variables, x2 and x3. x2 is defined as the first derivative of x1, x1 dot, and x3 is defined as the second derivative of x1, which is x1 double dot. Then we need the first derivative of the state variables, which are x1 dot, x2 dot, and x3 dot to construct the state equation. From the defined state variables in equation 3, we know that x1 dot is equals to x2, while x2 dot and x3 dot can be obtained by differentiating both sides of equation 3. Thus, x2 dot is x1 double dot, which also equals to x3, and x3 dot can be obtained from equation 2. Finally, equation 4 can be arranged and written in a matrix form to get the state equation as shown on the slide. So, we have done with the state equation. Now, let us move on to the output equation. For output equation, we will obtain it from the numerator block. From the block diagram, we can obtain equation 5. Then find the inverse Laplace by using differentiation theorem from Laplace theorem table and assume 0 initial condition. We will get equation 6. From the previous slide, we know that x1 dot is x2 and x1 double dot is x3. So we can rewrite equation 6 into equation 7. Finally, convert equation 7 into matrix form to obtain the output equation. Since we have obtained the state equation and output equation, the next step is to draw the schematic diagram. Similar to the example in the previous video, the green part represents the state equation, while the blue part represents the output equation, where it is the summations of 2x1 plus 7x2 and 1x3. For your exercise, you can try this example. The answer is given on the slide. With that, I end this video. Till we meet again in the next video, inshallah. Thank you for your attention.